What is stick welding? Stick welding is an electric arc welding process that uses rod-shaped metal electrodes that are covered with a flux material. The American Welding Society calls this process shielded metal arc welding, or SMAW. You may also hear this process called manual metal arc welding, or MMA welding. Some people refer to this process simply as arc welding, but shielded metal arc welding, or stick welding, is just one of many types of arc welding. In stick welding, an electric current flows through a metal electrode or stick. An arc forms between the end of this electrode and the workpiece. The arc melts both the metal in the rod and the metal in the pieces to be joined. The metal from the electrode is ejected into a molten weld pool and mixes or coalesces with the workpiece. The metal in the workpiece is called the base metal, and the metal added to the joint from the electrode is called filler metal. Stick welding always adds filler metal to the joint. Because the electrode is constantly melting away and becoming part of the welded structure, stick welding is known as a consumable electrode process. As the electrode is heated by the arc, some of the covering of the electrode releases protective gases that shield the weld and help stabilize the arc. The remaining covering melts and covers the molten weld pool with a protective slag layer. This slag layer protects and helps shape the weld as it solidifies, but it must be removed when the weld is cool. Since the gases generated by the flux covering are able to completely protect the molten weld, there is no need for other shielding equipment such as high-pressure gas cylinders, regulators, or hoses. Compared to other welding processes, stick welding equipment is often very simple. Sometimes the only controls on the machine are current and polarity. Many important welding variables come from how the person doing the welding positions and moves the electrode. For this reason, the quality of welds produced by this process depends greatly on operator skill. In stick welding, two insulated wires are connected to the welding machine. One lead goes to a clamp, which is connected to the work. This is called the work lead. The other wire goes to an electrode holder. The uncovered or grip end of the electrode is placed into the electrode holder. The polarity of the welding setup refers to how the electricity flows from the machine to the workpiece and back. The current will either be AC or DC. In AC, or alternating current, the direction of the flow of the electricity changes directions many times every second. Direct current, or DC, is like the flow of electricity from a car battery. One lead is always positive and the other is always negative. DC can be set up two ways in stick welding. One way to connect DC is DCEN, or DC electrode negative, which is often called straight polarity. In DCEN, the electrode is connected to the negative terminal and the work is connected to the positive. The other way to connect DC is DCEP, which is DC electrode positive, often called reverse polarity. Many stick welding electrodes operate on DCEP, but some are designed to work with DCEN or AC, so check the manufacturer's recommendations for the proper settings. Stick electrodes are made with a variety of metal alloy compositions and flux chemistries. You'll want to make sure the electrode you plan to use will be strong enough and that it's compatible with the base metal and the position of the joint you want to weld. Often, electrodes have the American Welding Society classification code printed on them. This code will identify tensile strength, the flux covering type, the appropriate welding positions, and sometimes other important information. So, in summary, stick welding is an electric arc welding process. It uses a consumable electrode rod that is covered with a flux material. When heated, the flux releases shielding gases that protect the weld. A layer of slag covers the weld while it solidifies and is removed when the metal cools. Stick electrodes are not all the same and must be chosen for the specific job they need to do.
That's where we finished, eh? So we need a crater fill. Oh, yeah, bitch!
What is TIG welding? TIG stands for Tungsten Inert Gas Welding. The American Welding Society calls this process gas tungsten arc welding, or GTAW. You might also hear it called heliarc welding. TIG welding uses a tungsten electrode, and tungsten has an extremely high melting point. When you TIG weld, the electrode gets hot, but it doesn't melt. We say that it's a non-consumable electrode. That doesn't mean it lasts forever. That just means that it doesn't melt and become part of the weld. You see, in a lot of other welding processes, the electrode melts and becomes filler metal. Those are consumable electrode processes. So here's the tungsten electrode being held in a TIG torch. The electrode slips into a collet, and and the collet tightens up against the collet body. You can adjust the length that the electrode sticks out of the holder by loosening up the end cap. When you tighten the end cap, the collet clamps down on the electrode. TIG works by melting the base metal, and that is the metal that makes up the two pieces that are to be joined. The heat is generated by an electric arc that forms between the base metal and the tungsten electrode. You can control the amount of heat with a foot pedal or with a thumb wheel on the torch. For most metals, the current is direct current, or DC. DC is like the current flowing from a car battery. One wire is always the negative and one is always the positive. In DC TIG welding, the electrode is usually negative and the workpiece is positive. The term DCEN is used for this, indicating that the current is DC and the electrode is negative. This is also called straight polarity, but DCEN is a more descriptive term. DCEN puts most of the heat on the workpiece, and it's the most common setup. When welding aluminum, however, AC is used. In AC, the positive and negative voltages switch back and forth between the electrode and the workpiece. This puts more heat on the electrode, but it has a cleaning effect on the workpiece. You see, aluminum forms oxides that float to the top of the weld pool and prevent a good weld. AC current helps control these oxides. In an electric circuit, the current flows in a loop. In TIG welding, the current has to flow in a complete circle from the machine to the torch, into the work, and back to the machine. A work lead is clamped to the work to complete the circuit from the workpiece back to the machine. Now, you can TIG weld with or without filler metal, and that's not a choice you have in a lot of other processes. If you want to add filler metal to a TIG weld, use a filler rod, which is just a rod of metal with a specific alloy. You want to make sure that the filler metal you're using is compatible with the base metal and that it has the strength required to do the job. In TIG welding, the molten metal is protected by a shielding gas. This gas, usually argon and sometimes helium or other gases, keeps the molten metal from reacting with oxygen and water vapor in the atmosphere. This shielding gas is stored in high-pressure cylinders like these. The pressure is reduced to a usable level by a device called a regulator. The shielding gas flows through a hose and comes out right at the point of the weld. So in summary, TIG welding is an electric arc welding process, uses a non-consumable tungsten electrode, the filler metal is added separately in the form of filler rod, and the shielding gas comes from a high-pressure cylinder. What is MIG welding? MIG stands for Metal Inert Gas Welding. The American Welding Society calls this process gas metal arc welding, or GMAW. You might also hear it called wire welding. In MIG welding, a thin wire acts as the electrode. This wire is fed from a spool mounted on a gun or inside the welding machine through a flexible tube and out of the nozzle on the welding gun or torch. The wire is fed continuously when the trigger on the welding gun is pulled. When this trigger is pulled, it also switches on the welding current and a shielding gas. An electric arc forms between this wire electrode and the workpiece and heats both metals above their melting point. These metals mix together or coalesce and solidify to join the workpieces into a single piece. The metal in these parts to be joined is called the base metal, and the metal that comes from the melting wire electrode is called filler metal. MIG welding always adds filler metal to the joint. Because the wire electrode melts as it's being used, MIG is called a consumable electrode process. Here's the MIG wire going through the wire feeder into a flexible tube or conduit liner. The liner goes through the hose or welding lead all the way to the torch nozzle. At the nozzle, the wire is fed through a contact tip and comes out at the point of the weld. Shielding gas is also fed through the welding lead. It goes through a gas diffuser and flows out of the nozzle. This shielding gas, which is often a mix of argon and CO2, protects the molten metal from reacting with oxygen, water vapor, and other things in the atmosphere. The shielding gas is stored in high-pressure cylinders like these. The pressure is reduced to a usable level by a device called a regulator. In MIG welding, all the machine controls are set on the machine itself. The most important of these are polarity, wire speed, and voltage. The trigger on the gun is just an on-off switch. For most MIG welding, the current is direct current, or DC. DC is like the current flowing from a car battery. One wire is always the negative, and one is always positive. In DC MIG welding, the electrode is usually positive and the workpiece is negative. The term DCEP is used, indicating that the current is direct current and the electrode is positive. This is also called reverse polarity, but DCEP is a more descriptive term. In an electric circuit, the current flows in a loop. In MIG welding, the current has to flow in a complete circle from the machine to the torch, into the work, and back to the machine. A work lead is clamped to the work to complete the circuit from the workpiece back to the machine. So, in summary, MIG welding is an electric arc welding process. It uses a consumable wire electrode. Filler metal is added automatically, and the shielding gas comes from a high-pressure cylinder. What is flux core welding? Flux core is an arc welding process that uses a tubular wire electrode with a flux-filled inner core. The American Welding Society calls this process flux cored arc welding, or FCAW. All flux core welding is done on equipment that is similar to, and sometimes identical to, the equipment used in MIG or gas metal arc welding. If you're not familiar with MIG welding, you might want to watch our What is MIG Welding video before continuing. But you should understand that flux core welding has some important differences from MIG welding. In flux core welding, the wire electrode is fed through a wire feed unit. Usually, this wire feeder requires knurled rollers that can grip the tubular wire without flattening or damaging it. As in MIG welding, an electric arc forms between this wire electrode and the workpiece. This arc heats both metals above their melting point. These metals mix together or coalesce and solidify to join the workpieces into a single piece. The metal in the parts to be joined is called the base metal, and the metal that comes from the melting wire electrode is called filler metal. Because the wire electrode melts as it's being used, flux core is called a consumable electrode process. Flux core welding always adds filler metal to the joint. The job of the flux inside the electrode depends on which type of flux core process it was designed for. You see, there are two main types of flux core arc welding: self-shielded, known as FCAWS, and gas-shielded, known as FCAWG. You need to be sure you're using the wire in the way that it was designed to be used, because the chemistry behind these two processes is different. Flux-cored electrodes that are designed to be self-shielded contain a flux that completely protects the molten weld pool. The flux in these electrodes creates a protective cloud that prevents gases like nitrogen and oxygen from reacting with the hot metal. One advantage of the self-shielded flux core process is that the added cost and inconvenience of gas shielding equipment is eliminated. Also, self-shielded electrodes are less sensitive to drafts and breezes that easily contaminate gas-shielded processes like MIG welding. This can be a real advantage in some applications. Electrodes designed to be gas-shielded rely on a secondary shielding gas to do the job of protecting the molten weld. The high-pressure gas cylinders used for this process are of the same design as those used in MIG or TIG welding. These cylinders contain gas under extremely high pressure, and a device called a regulator brings the gas to a usable pressure. One of the most common gases used to shield flux core is pure CO2. Other gases, such as CO2 argon blends, are also used. But one advantage of flux core G is that low-cost CO2 can be used to shield the weld. Another benefit of gas-shielded flux core is the high deposition rate that can be achieved with the combination of flux and gas. Gas-shielded flux core has the ability to lay down metal at an extremely fast rate. In both the self-shielded and gas-shielded processes, the flux forms a thin layer of slag that protects the weld as it cools. This slag also helps the solidifying weld to take a consistent low-profile shape. In flux core welding, all of the machine controls are set on the machine itself. The most important of these are polarity, wire speed, and voltage. The trigger on the gun is just an on-off switch. For most flux core welding, the current is direct current, or DC. DC is like the current flowing from a car battery. One wire is always negative and one is always positive. In self-shielded flux core welding, the electrode is usually negative and the workpiece is positive. The term DCEN is used for this, indicating that the current is DC and the electrode is negative. You might also hear this called straight polarity. In gas-shielded flux core welding, the electrode is usually positive and the workpiece negative. The term for this is DCEP, indicating that the current is DC and the electrode is positive. This is also called reverse polarity, but DCEP is a more descriptive term. Keep in mind that these are the most common settings, and always check your manufacturer's recommendations. In an electric circuit, the current flows in a loop. In flux core welding, the current has to flow in a complete circle from the machine to the gun, into the work and back to the machine. A work lead is clamped to the work to complete the circuit from the workpiece back to the machine. So in summary, flux core is an electric arc welding process. It uses a consumable tubular wire electrode that contains flux material on the inside of it. Filler material is added to the weld automatically as the wire electrode melts. In self-shielded flux core, the weld is protected by the flux itself. And in gas-shielded flux core, the shielding gas comes from a high-pressure cylinder.